All right, so let's move on to section 12.2, which is going to have two tests that, I don't know how to describe it. They're actually the same kind of test. They're not different in terms of how you run them. They're different in terms of how you think about them. So the first thing we're going to deal with is a test for independence. Is one variable truly independent of another variable? And we've dealt with this topic of independence before. Remember talking about, whether your sample is independent, talking about whether one event is independent of the next event and probability. All of those things were kind of leading up to this moment. So what is independence? It means that, of course, one thing happening has no effect on the other thing happening, right? So, for example, can money buy happiness? You always heard the Beatles song, "Can't Buy Me Love." Is it true? The following table shows the results related to happiness and family income from the 2002 General Social Survey. And again, that's a very large survey that's done of Americans. It happens very often, et cetera, et cetera, et cetera. We've used it several times. All right, so we're going to find the totals for the rows and columns. This is just a refresher of what we did in chapter 4, believe it or not. This is called a contingency table. These are qualitative variables. I am not happy. I'm pretty happy. I'm very happy. Those are words. 21 people said they were not happy and above average income, and so on. So what we're going to do is we're going to copy and paste this into Excel. And I haven't saved this. I really should. Save as. I'm going to save it as chapter 12. Hold on one second. Chapter 12, sorry, dash 13 technology. Remember, we're going to be doing 12 and 13 together, so we'll throw those two in there. And of course, if I change my mind on that later, then make it just chapter 12. But currently, that's the way we're going to roll. All right, so what I did was I copied and pasted that lovely table right here. See it? And what I want to do is I want to find the totals. So I'm going to find equals sum of these three cells right here. I'm going to drag that down. And then over here, I'm going to do equals sum of these three cells. And of course, you could type B3 colon B5 if you liked. Enter. And drag them across. So we have a grand total of 1362. Isn't that beautiful? Everything's great. We learned all this back in chapter 4, right? So this is the actual data, happiness data, raw data. Let's put it that way. Cool. All right, so I will copy and paste those values back into my, you don't have the ability to copy and paste. You're just going to be typing them or writing them yourself. I'm sorry, but there you go. Okay. Oh, and while I'm on this subject, from 12.1, I called that 12.1. I should say what example it was that we were working with there. It was 12.1 example 2, I think. Let's double check. Well, it was really 2 and 3. So it was kind of, here, 12.1, excuse me, examples 2 and 3 or something like this. And this is 12.2 example 1 that I'm working on. Although I think it'll end up being more than just example 1, but I could just say 12.2. Well, let's just start with there. All right, so we've done with that. Now, conditional distribution. I bet you don't remember how to do that. That's okay. That's what I'm here for. All right, so we're going to find a conditional distribution of, let me read what it said, of or for happiness by income. So we're going to take these income levels and go across. So there's two ways you can go make a conditional distribution. You can go across the rows, so by the rows, by income, which is what we're going to do, or you could go down the columns. So there's two possible conditional distributions. We're going to go across. I could have made you also do one that would have been by happiness level. So I could say for happiness by income, which is what we're going to do, or I could say for income by happiness, right? So how does this work? Well, what you're going to do is you're going to take 21 and divide it by 290. Then you're going to take 159 and divide it by the 290. And then 110 and divide it by the 290, and so on. And then 53 divided by 646, etc. And we're going to do this in Excel, for sure. Divided by, so B3 divided by 290, give that sucker dollar signs. And then equals 53 divided by 646, give that one dollar signs. So E4. And then again, equals 94, divided by, where's my divided? There it is. 426, give it dollar signs, F4. All right, now grab those three cells, move your cursor to the bottom right so it makes the handle, and drag it across. If you've done it right, these should make 1 by the time you're done. Coolness? Great. Awesome. So I'm going to copy and paste these. If you want, if you don't like all those decimal places, if you think, oh, that's kind of hard to read or whatever, you could always format the cells number and make it so they've got like 3 decimal places or something like that, if that's easier for you to read. All right, let me go back here. Done. Beautiful. All right, now what does it mean to be independent? If you have 2 categorical variables that are independent, if the population conditional distribution for one of them are identical at each category of the other. So the variables are dependent if the conditional distributions are not identical. In other words, if when you look across here, and then look across here, and then look across here, are you getting the same thing every time? And the answer is no, right? So just for the fun of it, I graphed what we had. And you could too, as a matter of fact. Hold on. Let's add that to your lovely. And you don't need the ones. Don't grab the ones. That would be bad. But you can grab these guys. You can grab the above average along with them. Insert. Let's see if this works. Beautiful. Gorgeous. We don't want, you know what? Delete that. What if I grab that income label thing? Will that do it? Oh yeah, there you go. Look. And you can see here, if you look at, here's a group of people that are not happy. Who's way more likely? Look at that green bar. See that? And if you want, you can click on these bars. You can click on the bars, right click, and you can choose to add data labels. And you can add them to the right ones, add them to the, or excuse me, add them to the blue ones, add them to the green, add them wherever. You can add in labels and you can see, look, 22% of this group, what do you mean? 22% is the not happy below average, right? And then over here, only 7% of those not happy people. I mean, it's not quite right for interpretation. I'm trying to get my head to work. It's really what you're saying is, look, if you compare all these green bars, see the green bars, 22, 585, and so on, right? They add up to 1. So of the below average income people, 22% of them are in the not happy group. If you look at the above average income people, right, the blue bars, they add up to 1, those 3 blue bars, but only 7% of it is in this not too happy group. See what I mean? And that should cue into you that it's not independent, right? And that's what we're seeing in this picture. This is the same picture that we just had made in Excel. I just didn't label stuff, but it's basically the same. Right? The not happy group people are twice as likely to be in the below average income than they are to be in the other ones. Like this is 8.2% and 7.24%. 22% are in below average. Right? That means that if you're a below average income, 22%, you have a 22% chance of being unhappy. By the same token, the very happy group, the people that are below average income, there's only 20% of the people that have below average income are in the very happy group, right? But 37.93% of the above average income people are in that group. So you're more likely to be high income if you're very happy, and you're less likely to be low, you're less likely to be happy if you're high income. Excuse me, getting grief. You're less likely to be poor if you're very happy, right? So look these over, see if it makes sense. Below average, much more likely to be not happy, much less likely to be happy. So this is a poor person, right? Somebody who has below average income. They're less likely to be very happy. They're more likely to be not happy at all. Right? So we're seeing that it's not true that they're independent. If they were independent, then what would the bars look like? They wouldn't show this marked difference, right? They'd be kind of equal-ish, right? Kind of how you see in the pretty happy group. It's like, you know, they're about the same. But this significant difference that we're seeing here, especially with that below average, especially people that don't make a lot of money, there's a big difference between them and the rest of the people. Okay? That would betoken to us that is not independent. If it was independent, if your income and your happiness level were truly independent of each other, then it wouldn't matter whether you were below average. They'd all be equal, right? Equal bars on all 3. All right, so but even though we can see this visually, right? Hopefully you can. How can you be more certain, right, that income and happiness are not independent? Well, you can conduct a test, right? Of course you can. The chi-square test for independence, right? We're going to run it. I'm going to flip down. It's down here. There's 6 steps and all this good stuff. Before we get into it, though, we've got to learn how to find the expected counts. We need to have expected counts, and it's not as easy as it was in 12.1. Let me remind you about 12.1. 12.1, you just take the percentages. This one was particularly easy because they were all the same, but you take whatever the proportions are and you multiply. You'd say, okay, 13% times, 1,000 M&Ms, 14% times 1,000 M&Ms, and so on. You get your expected counts that way. Or in our case, it was a 12th times 1,067 every time. But down here in 12.2, we're going to have to work for it a little bit harder. Now remember, the rule for independence from chapter 5 was that if they're independent, then you should be able to multiply probability of A times the probability of B and get that probability of A and B. That's what we're going to use, essentially. We're going to multiply our row total times our column total divided by our total sample size. And we're going to find these cells. And we're going to do it in Excel. Yes, indeed. All right, so let me move this sucker over. All right, I gave it down here. I just kind of copied and pasted the table in again. So we want to take the row total. So you take the row total, which is 290. Oopsie, I don't know why I closed that parentheses. Times 168, the column total, divided by 1362, and give that sucker $signs. All right, and then you do it again. So equals, we actually don't need to bother with $signs because you're going to kind of do this every time. We want the row total, which is 646, times the column total, which was 168, divided by 1362. And it doesn't even matter about the parentheses. I just thought of it because since everything's multiplied. So 168 times 426 divided by 1362. There we go. And then do it again. So 780 times 290 divided by 1362. All right, I'm going to pause you and I'm just going to keep doing that over and over and over and over and over. So you pause me as well and then finish the rest yourself and then check your totals with mine. All right, last one. 414 times 426 divided by. There we go. We don't need the total thing. It's useless. All right, there we have them. And if you want to format those cells so you're only keeping, 3 decimal places or something, just highlight them all, right click, choose format cells, give yourself some decimal places and call it a day. I don't care personally, so I'm just going to keep all my decimals. I'm going to put them in here. Whoopsie. There we go. All right, so if they were independent, this is what you should have gotten. You should have gotten 35 in that first group, 166 in that next group, and so on. So if they were truly independent, this is what should have happened. Now, the test for running this. So you can see, lovely 6 steps, same as usual, blah, 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 blah. How do we get it to run it? So let's see this output, and then I'll pick up here next time. So you go to StatCrunch. Oops, StatCrunch. And you can actually just put in the raw numbers you had. You don't even need the expected values or anything. Oh, this is another way to find expected values. I should have told you this. So you got all these things in here. This is the original data, 21, 53, 94, and so on. And I put in my category names and all that good stuff. So I go to Stat. Let's see, where is it? Tables. And then choose, Stat, Tables, Contingency with Summary. And you say, okay, I was in not too happy, pretty happy, very happy. My row labels were in that income. That's where right? So you pick all the data columns. Those are what you pick up here. And then you say your category name. So you got to have those typed in. Next. Click expected count and chi-square. Calculate. And this is where we'll have to pick up next time. But this is how you get it. And copy and paste it into Excel.